Okay, this video is going to deal with our last lecturable chapter, which has to do with methods. And we're going to talk a little bit before I get into this about why we use methods. Methods are created for several reasons, but mainly it's for code reuse and maintenance. And let's just say, for example, you have a program and the program gets some input and has some variables, and then it comes down to a decision. And if it's a dual alternative decision, you do something if it's true and false, excuse me, or false, can't be both. So if the decision is true, then you come over here and you do procedure A, B, C, and D. All right. If the decision is false, you only do processes A, B, and C. So if you can see this in your mind's eye, then it looks like we're duplicating A, B, and C regardless of whether it's true or false. Of course, you could say, well, I'll just put it in, but it needs to be done first. So there's some duplication there. If you expand this example slightly, then you will see that if I've got 10 places where I've got duplicated code, that code, those processes could be pretty verbose. They could be relatively large, hundreds of, perhaps thousands of lines of code. So I would have all this duplicated code. Not only does that blow up your program in size, but if something happens, you find errors in that code or maintenance changes or whatever, now you've got 10 places where those changes have to be applied. If you take that code, on the other hand, and you put it in one place by itself and call it something, and then in those 10 places, rather than having all those hundreds of lines of duplicate code, you simply call that code that has its own location, then that will simplify things greatly, especially if you want to reuse it. It's already in one spot in other programs as well. You just pull it in. Or if there's a maintenance change or an error in that code, then there's just one place to go do it. It's sort of like using named constant. Let's say, I think we've used the example pi, right? And you initially wrote the program, and this was the requirement that pi only go to 2 decimal places, so 3.14. And later on, and you haven't used pi, where you just use it in one spot and just use the name constant pi to represent that. Then if later on someone comes back and says, I need it to 16 decimal places, well, you just go to that name constant up there. Instead of 3.14, it's 3.14159, blah, 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 however far out it goes. You don't have to run pi down everywhere because you haven't hard-coded that number all over the place. Same idea here. But even beyond that, on the extensibility and sharing and reusability, that's really important for software development costs and maintenance costs too. So you can port that out to other programs, and it's hard to find examples in what we're doing where that would be the case. But if I had a method that I had developed for printing and it worked pretty well for Windows printing, then I wouldn't have to rewrite that every time and reinvent the wheel. I would just include it in my program, reuse it, and call it. Okay, and it's pretty easy to do, actually. All right, here is an example that I started off, and I figured we'd used this before in class, so you'll be familiar with it. It just calculates the area, and there are 3 variables: length, width, and area, and then there are 2 inputs. So I get the length, and I calculate the area, and there's my processing, and there's my output. So let me just run it for you real quick. 10 feet and 10 feet, so now I've got 100 square feet. So that's pretty straightforward. But what if I wanted to use this particular code and I wanted to use it in a lot of different places? Well, obviously I wouldn't want to repeat all this code everywhere. All right, and again, this is an oversimplification, but it does the job. All right, before we start flying off in Visual Logic and creating and me showing you how to do this, let's go and look at a little pseudocode here. All right, and what I've done is I've got my start and my stop. So this would be my main line procedure, and then I've got my little method here, and this is where I'm going to encapsulate this code. And I've got to talk to you about a couple of things, not a lot, but a couple of things before we go any further here. All right, so here's my mainline code. I've got my length, my width, and my area, and I actually forgot my input statement, so let me do that since I forgot it. Input, length, and width. Might help if I thought this through, right? Okay, so I get my input for length and width, and then I'm going to, rather than calculate this out the way I did in the main line, I'm going to encapsulate that area calculation in something that I can encapsulate and call from other places and just put it in one spot. And I've called this calc area. All right, so this is the location at which I'm going to, in which I'm going to place my calculation code. So, all right, so I've got my argument list. Now, what this means is an argument list can have no arguments in it or any number of arguments. And an argument is simply a way to push data from one location in the program to another. And this happens, the compiler does it for you. You really don't have to know much about it other than the way they're passed in, not really how. All right, so this particular method has 3 arguments. All right, they're of type numeric because these are numeric, and they're length, width, and area. Now, these arguments are not the same variable as length, width, and area. They're different. They're temporary. These only exist by default as long as this thing is being executed, right? Whenever execution jumps, and it does jump to the, from the calling code to the code that's being called, when that happens, then these come into existence. They don't happen before and they don't happen after. They're gone. They're temporary. These are created on what we call the stack, which is fast RAM, right? And, so this all came about when memory was at a premium. But in any event, so I come down here and I pass in the value stored at length, width, and area. All right. Let's say, for talking purposes, that length was 10, just like we just did, right? And that width is 10. All right. So that's just a comment right there. There's nothing to do with the code. So we got a 10 and a 10. So now we have a memory location pointed to by the name length, and a memory location pointed to by the name width, and a memory location pointed to by the name area, which you already know about that because I've drilled into your head ad nauseum. And in length and width, we have stored a 10 and a 10 because that's what we got from the user in our input statement for our hypothetical here. Now, before, what we do is we just say area equals length times width. Well, 10 times 10 is 100 because these names point to the memory locations. And then we'd have the assignment for area, and in area at the end we would have 100, and then I'd have output area is and an area. Okay. Well, it doesn't work quite that way with methods. All right. So what happens here at our call? This is where we're going to call this method that we've got down here, and this could be in another file or somewhere else. Execution will jump from the main program down into here. It will do its thing, and then return back up to the next statement in the file. In some languages it's the same line, but for now we'll just go with that. Now, how does that work? Well, remember I told you these are temporary and by default. Now, you can override that, which we're going to talk about momentarily, but in any event, what happens is if I declare this method with 3 numbers, 3 arguments of type number, then I have to have the same thing down here. So now, these are not the same variable, so I'm using different names. You could use the same name because they're different, but it's a little easier, just keep this in mind, if you keep these similar but different. So I'm using L for length, W for width, and A for area. You can use whatever you want. It's just easier to keep them separate this way. So what will happen is, because I'm using the names here, it will pull the value out of that memory, pass in copies of it here, and then we'll do our little thing, and then when this returns back, these are unchanged because we're passing copies of these, and these are temporary. All right? So let's look at this. So I'll get a 10 stored in length and a 10 stored in width. I'll make my call to this procedure, this method down here, passing in copies so that here I have a copy in L, which is 10 is stored, in W where a 10 is stored, and then area, which was 0, right, because I didn't get anything, we're going to calculate that, it would just pass in a 0. All right? Okay. So now I've got to flesh this out so it actually does something. So I would put A equals L times W. All right? And then I will have to move my output statement here because I won't have any way of getting area back up in here because these are just copies and they're temporary, right? So they don't exist. Once I go back up to here, area is still 0. Length is 10, width is 10, but area is still 0 because this is a totally different variable and it's only temporary. You can't see A from in here and you can't see area from in here, right? That has to do with lifetime and scope. So I'm going to put this would now be A. And what will happen is I'll pass a 10, a 0 in here, and these are copies of L width and length, width, and area stored in L, W, and A. So I got a 10, a 10, and a 0. Now here's my assignment. A, assignment L times W. So this has 10, this has 10. 10 times 10 is 100, stores it in A, which all these are temporary. They don't exist after this runs and exits. And I do my output. Area is A, so A would be, it would show 100. And I return back up here and stop the program. All right, so now I've got all this encapsulated. The only thing I have to remember is if I ever get ready to use this code, all I have to know is what it expects in the argument list and what it's going to output, which is the area. Then I can call this from anywhere just with this one line of code right here. All right. Now, by default, we pass these copies into the argument list, right, as a certain way. They're copies. So that's called by value. All right. So that means we're passing copies. There are times when you want to pass in what we call by reference, right? What is a variable name really? Does it have a value? No, other than a hexadecimal value of the starting address of memory. Remember that? Look at this. Let's go back and let's rehash this. This is a variable declaration. It is of type number, and it has a default initialized value of 0, and the name that points to the memory location that's going to be returned to us from the operating system is called length. All right. So when the compiler sees this, it asks the operating system, please give me a piece of memory big enough to hold a number. And when you do, give me the hexadecimal starting address of memory, and I'm going to assign it to this, point this name to it. After that, then we're going to assign a value of 0 to that. So all these have zeros. Then they get 10 because we're getting everything but area. Okay. What if, for example, I wanted to make sure that I have my output statement here? Okay. Well, let's look at that. I still have 10 for width and 10 for length, and I have 0 for area because we haven't gotten anything for that. We're going to calculate that. So here we're going to call this function, right, this method. We're going to pass in a copy of 10, 10, and 0, and that's what we get here. So A equals L times W. Well, A is going to be what? 100 when this finishes. Come back up here. Now what do we got? Area is area. What does area hold? 100? No, it holds 0 because these are gone once this finishes and comes back up here. So how are you going to handle that? Well, that's the optional method, not the default way, which is by value, but what we call by reference. And typically you'll have something like a keyword that would tell it this argument is by reference. Now what does that mean? If the default is by value, which is simply passing in copies, then by reference means we're going to pass in the hexadecimal address that was assigned to this name when we created it. Remember that? That way, A here points to the same memory location over here. If I drew a little picture, I wonder if I could draw something. Yeah, I'll draw a rectangle right here. Okay. This is area. All right. Whoops, didn't want to do that. All right, so this is my memory location pointed to by area. If I could draw an arrow, it would point here, and I'm not going to do that because it's too much trouble in this software, as you well know. Area has a value of 0 in it. Let me blow this up substantially. All right, so that's because we created area and we put a value of 0 in it when we created it. And now area points to the beginning of starting hexadecimal address of memory, starting right here. Okay, so these two are passed in by value, and this one's passed in by reference, per our discussion here, right? Okay, so we come in here, so we get a 10 for L, a 10 for W, and some funky hexadecimal address that actually points to this memory location. So now area and A both have the same hexadecimal address, which means they both point to here. So whatever I do to A is reflected here, and when I get back up here, area has that same value because they both point to the same thing. And I wish I could draw some sort of, I can't do it in here, it won't let me, so never mind. All right, so, but area points here and A points here, or whatever this argument is. All right, let's run through this. Okay, we got 0, 0, 0. We create these and assign values to them. Then I've got input length and width. So we get 10 and 10, and we call this calc area method. So I'm passing in a copy here, and then the hexadecimal address of memory, which points over here. Okay, because that's what we've got. All right, so we're passing that in, and all of a sudden I've got a 10 copy, and a hexadecimal address here. All right. So 10 times 10 is 100. I have an assignment statement. 100 gets assigned to the memory location pointed to by A over here, which guess what? It's the same one pointed to by area over here. Now area has a value of 100 in it. So when I output area, instead of getting a 0, I actually get the 100. Okay? Now that's the difference between by value, which is the default method, not meaning method, default function of the way that it passes it in, versus by reference, which is you have to specifically tell it that, but when you do, then it points to the same thing. So here, if I wanted to, if I came in over here, since L is passed in as is W by, default by value, I could say L equals 1,000. All right? Okay, so I come down here, and length is 10 and width is 10. I pass in all this in, so it jumps. Execution jumps from here down into here, passing a copy 10, and this is a hexadecimal value. A equals 100, or it's the value, the memory address is the value stored there. And then L equals 1,000. Well, I'll come back up here, and I output area. Area is 1,000, but what is the value of length now? Well, it's certainly not 1,000 because L is simply a copy. It's passed in by the default. So when I get back up here, L is unchanged. L is still 10. All right, that's the difference in passing by reference and by value. So now let's go back, if you got that, and let's port this over into using a method for calculating the area. All right, how do we do that? Well, first thing you want to do is add a new procedure. How do I get this? I right-click. There's main. This is main, right? That's what it's called. That's our main procedure. I'm going to add a new procedure. I don't have one, so I can't call it if I don't create it. And there it is right there. New procedure. What am I going to call this? Calc area. All right? Now, here are my argument list. I want to click new, and I'm going to create a new argument, and I'm going to call this one length. Okay? Another one called width. Now let's start out with just these. Well, let's go ahead and add area. All right. So how many arguments does this procedure take? They call it procedure in Visual Logic. It's really a method or a module or a function, whatever you want to call it. All means the same thing, basically. There are some semantic differences between procedures and functions, but not in what we're doing. So calc area takes 3 arguments. All right. So now I've got the shell for calc area. So I call these length, width, and area, but you can always go in there and change those if you want to edit them. You can change this to L. It might be better to do that, just in keeping with my example, I guess. And then A. Edit. You can edit these once you do them. All right. Now, if I go over here back to main and I right-clicked, and you can also do it up here, and I put in a method call here and I change that method, I'll have to go in and delete that method call and re-add it in. I'll show you that later, but it's just an issue with Visual Logic. But in any event, all right. Let's put in the functionality in here for our calculation. So I've got A equals L times W, right? And there it is. If I want to put in space for readability, I can certainly do that. All right, so let's right-click and go back to main. You can go back and forth this way. So there's my length and my width. Now I'm going to delete that. I don't need that. I want to create another method, and I'm going to call this one output area, or just, out area. So let's create another one. We'll call this output area. All right, I'll take one argument. It's going to be area. Again, that's just an argument. All output's going to do is just output whatever's passed into it, and its area. So I'll tell you what, let's do. Let's add, it might help if I spell that correctly. Let's add something else to this. Let's add let's add another one called prompt. Okay. All right, so I've got my number, and the prompt's just going to be an output string. So this thing's going to take two arguments and just output them. That's all it's going to do. Did I misspell that again? I did, didn't I? Area. No, that's right. It look right. Long day. Okay, so I just need an output statement in here. All it's going to do is output two things, and those are the arguments that are passed into it. So, thanks. Like I care about that. All right, so I'm going to output the area is, whoops, wait a minute. Let's do it like this. Prompt ampersand area. All right, that's all it's going to output. The two things that are passed in, we don't even care what they are, okay? Just prompt and area. That's all it's going to output. And whatever I pass in as prompt, it's going to stick in the front. Whatever I pass in the area, it's going to put on the end. And now remember that in Visual Logic, the ampersand does a couple of things. One thing is it ensures that both conditions, one on each side of that ampersand, are both strings. If they're not strings, it converts them to strings. Then it concatenates them together and it just into one string. That's all it does. Okay, so we know that. All right, let's go back to main. All right, let me grab this. Well, nah, there's no need to grab that. Let's just delete it. All right, so all we have back in our main here is our three variable declarations or our two input statements. What we have to do now, well, let's see, is do a call procedure. Now notice that I've got these two procedures here that I can call. Before I had to add them because I didn't have anything. So that tells you right there that if you've got a program where you got a bunch of different methods that you got to create, it's best to just go ahead and create the shells for those and get the arguments right and get the call locations right before you ever start worrying about the logic. It's a lot easier that way. So I'll do calc area, and that's what a call statement looks like. And then I'll do, let's see, call procedure, I'll do output area. All right, and then I'm done, okay? And I could even do one that would actually input these. As a matter of fact, I can, well, let's just do it this way first, and then I'll show you. All right, what does calc area do? Well, it's going to pass in length and width and area, hopefully, and calculate the area. So notice here that the arguments that are listed are the ones shown on the actual method that I created, L, W, and A, not these, okay, because they're different, all right? So I double click on this. What I see here is the call name for the procedure and then the arguments. Now, these are the formal arguments. These are the ones that exist in the function or the method. They're temporary in this case, okay? Now, these are the ones that I'm passing copies or references into. So what will go here is length, because that's what's in main, width, and what? Area. If you forget to do this, you're not going to get anything but some problems, okay? So you have to make sure you do it. All right? Now, if I go over here into calc area and make a change to this, not to the innards, but to the actual header, the number of arguments or the type or whatever, then I'm going to have to go back to main, and this is a Visual Logic thing, all right? If you make a change to the, remember this, you make a change to those, you're going to have to delete this call and add it back in again because it won't pick it up automatically. All right. So I'm sorry about that, but that's just the way it is. Length. Let me go ahead and put this back in. And that's pretty common, actually. You make changes to this quite a lot. It's too bad it doesn't pick it up. All right. So what will happen is we'll come down here, and this will begin, load into memory with the begin. It will create these three variables and initialize them to 0. Do two inputs and store the whatever you get from the user into the length and width. Then it's going to pass the value stored at length and width and area in as copies here. All right. At that point, execution will jump over to this location, and in main it will pause. It will be in abeyance. It will pass in a copy of 10, 10, and 0 because there's a 0 stored at area. All right. Then it will calculate 10 times 10, which is 100 stored in A, and then execution will jump back to main, at which point it will call area, the output area. So what are we passing in? The area, which is actually stored at area, and these are two different variables. I can change the name or use the same one, but they are different. These are temporary. This is the one in main. So your actual arguments are the ones in your calling code. In this case, is the main procedure. What's the prompt going to be? Well, it's just a string. It'd be whatever I want it to be. In this case, is the area is colon space, right? That's all that is, just passing in that string. And then it's going to jump to output area, at which point I've got a copy of this, and it just outputs it. All right, so let's go to main. Let's save all this, and let's run it and see if I got any errors. Length is 10, width is 10, area is 0. Uh-oh. It did output it, though, didn't it? What was the problem? Well, the problem is everything is passed in by value, which is a temporary copy. So when this returns back to main, A is gone. There's nothing in, A doesn't exist, right? What we have to do is we have to pass this in by reference. All right, so I got to go back here and edit this and set A, let's see, wait a minute, edit, yeah, to by reference. That means it passes not a copy, but the actual hexadecimal address, so that when I change A here, it changes area in the calling procedure, which happens to be main. All right. Having said all that, let's see if I got this working now. 10, 10, 100. There it is. See that? See the difference? Now A is the same as area. So when I change the value of A here from 0, which was passed in, or actual hexadecimal address, to 100, and I made this assignment, area and A point to the same memory location. Remember that? See? That's how that worked. All right. Now, let's do something a little different. Now, you can have as many of these by reference as you want, or by value, or any combination, depending on what you're doing. Length and width don't need to be passed in by reference. We don't care if and we're not going to change them anyway, but even if we did, we don't want these to change. We want these to remain 10 and 10. So you just leave those alone. But area needed to be done that way because otherwise we'd have a 0 in area because the A value we calculated here goes away when control returns back here. All right. Now, I've got my output here, but I could just as easily, and it would make main smaller if I delete that call and actually go into calc area and call the output method from there. I can call one method within another method within another method. I can have 15 method calls, or I can have method A call method B and C and D and so forth. So there's really no set way to do that, just how I want. So I can put this here, and I can come in here and put A, because now we're talking about a different variable here, A. And again, I just have the same thing. The area is colon space. Now let's run it. Let's go save it and go back to main and see what happens. 10, 10. Execution jumps to calc area. Then execution jumps from calc area to another procedure called output area, which it didn't run. I don't know why. Let's see what happened here. Call procedure, output area. Whoops, nope. Why didn't it output? Huh. What is going on here? That's odd. I don't know what's going on with that. I'm going to have to figure that one out. Let's try it again and save it. Right. 10, 10. Huh. That's odd. I'll have to figure that one out. Just blew that up, didn't I? Okay, well, we'll put it back here for now. I'll have to figure out. It's been a long day. Something pretty simple as typical. So here we put area. But you can call one from another. In fact, I'll do that in just a minute. We'll set up something a little bit different here. And this would be the area is. And I need to talk to you about that anyway. Okay. So when that runs, this code will jump to calc area, and then it'll return back here, and then this will jump to output area. All right. So let's say that we're going to delete all of this, and we're going to do something totally different, something much simpler. All right. I'm going to, I don't know if I can delete these or not. Let's see. Let's just start a new thing here. No, we want a new one. Okay. Here's our new one. Now, I'm going to create some procedures. I'm going to call this proc A. All right. And then I'm going to create another one called proc B. Whoops, don't need any spaces in there. All right, there's proc B. Let's put outputs in this. Let's see. In proceed. Let's call it method. In method B. Method has an E in it. Method B. All right. All this does is when it gets called, it just outputs that. Let's go to procedure A. And let's put output here. In method A. Okay? And then we'll go back to main. And we're going to put our calls in here. There's procedure A and procedure B. We're not passing any arguments in. And methods can have no arguments at all. They can have none. They can have 1, 5, whatever you need. If you have more than 5, you probably need to rethink it. So all main's going to do is start. It's going to call procedure A and procedure B. Okay, and then that's all it's going to do. So let's run it and see. There's method A and there's method B, and we're done. All right, now everything's linear, right? It comes in here, calls this, calls this. If I had more, it'd be procedure C and so forth. But what I'm trying to show you here is, if I can do this without screwing everything up, let's go to A, and in A, instead of jumping back to main, let's put that call in there to B. Okay, so now what's going to happen is main's going to call A, and execution will jump from main to A. Right? It will output this, then it will call procedure B, which means now execution jumps to B. Then it outputs this, and when it finishes, it jumps back to A, all right, which then returns it back to main. So there's kind of a sideways linear thing here. Main calls A calls B, B returns back to A, and A returns back to main, all right? It's like a linked list, like a daisy chain. Main to A to B, B to A to main. My point here is that you can have procedures calling other procedures, which call other procedures, which call other procedures, as much as you want. You don't have to have everything in main just saying call procedure A, call procedure B, call procedure C. You can have one procedure call another one. Well, main is a procedure too, right? So that's why that works. Now let's run this, see what happens. A, there's B. Okay, now let's beef this up a little bit. Let's put an output here that says in main. All right, that's all that's going to do. And let's make a copy of it, put it down here, and say back in main. Okay. So we do in main, procedure A, procedure B. All right. Now let's go to procedure A. In method A, in method B. Okay, let's go back to A. Now here I'm going to put an output that says returning to A. Returned to A. Okay, so this goes output, this goes in method A, then we go to procedure B, which goes in method B, and then we go back to here, it says return to A, and then we're going to go back to main, it says return to main. Let's do that, return to, try to be consistent anyway. All right, excuse me. Let's run it. We are in main. Okay, then we're going to jump procedure A, and procedure A says we're in method A now. Okay, then it goes to B, then it comes back to A, and it says return to A, and now it's going to jump back and come back to main from the call to A, and there's return to main. Okay, see how that works? It's sort of a sideways linked list, and one procedure can call another and another. I think that pretty well does it.